Okay, so now we're going to be talking about factors affecting reaction rates. Again, remember, kinetics, it's the study of the rate of the reaction, or how fast a reaction occurs. And again, remember from our last video, collision theory states that reactants must collide with the correct orientation and with enough energy in order to form new products. So in order to increase the rate of the reaction, particles must collide more frequently and or with more energy. So the 5 different factors that affect the reaction rates is concentration and the surface area of solids, pressure of gases, and the temperature and the presence of catalyst. So the very first one, increasing the concentration of the reactants allows there to be more collisions. It's like if we were at an amusement park and we had some bumper cars over here. Some people were playing at a lot more space to play in. There's not going to be as much collisions. However, once all these people are noticing how fun these guys are having over here, they're going to want to get in their own bumper car and participate as well. So as we increase the amount of bumper cars, there's going to be more collisions. So this is going to increase the amount of collisions. And if we have more collisions, there's going to be more chance that the collision is going to, or these particles are going to collide in the correct orientation and with enough energy in order to react. So this will increase the rate of reaction if we increase the concentration. Now the next one, increasing the surface area allows for there to be more chances for collisions. Now this is of like solids. So if we have some solid crystal right here, like salt for instance, or a sugar cube, when we put this into water, the water molecules can only dissolve the very outside molecules. It can't get at the molecules inside here. However, if we crush up this sugar cube into a bunch of small pieces, all of a sudden the water molecule is able to get at a lot more molecules. All of a sudden this water will be able to get at all of these water molecules, all of these water molecules, all of these ones, all of these ones, all of these ones besides this very inside one. So there's going to be more chances for collisions, more chances for the collisions to be in the correct orientation and with enough energy. So we're going to increase the rate of the reaction. The next one is increasing pressure. Remember from the gas chapter we talked about how when we decrease the volume, now look at this box right here. We're going to decrease this volume. And all of a sudden there's going to be less space to move around. These particles get closer and closer together. So they're going to be colliding more frequently, they're going to be colliding against the walls more frequently, the pressure is going to go up. So that's really increasing the concentration. Remember, molarity equals moles divided by liters. And if we take a liter of gas and put it into a half liter, this liter right here is going to get smaller. Well, if it gets smaller, we're going to be dividing by a smaller number, so this big M goes up. So that's like increasing the concentration. Again, if we increase the concentration, there's going to be more collisions, which is going to increase the rate of reaction. Now, one thing that's important to remember is that this only applies to gases. Not liquids or solids, only gases. The next one is increasing the temperature. Now remember, kinetic energy is talking about the average, or increasing the temperature is talking about the average kinetic energy. So if we increase the temperature, we're going to be increasing the kinetic energy. Well, if we're increasing the kinetic energy, particles are going to be moving faster, so there's going to be more effective collisions. Or in other words, there's going to be more collisions that have enough energy in order to react. It's kind of like if we had a car. If we were at a stop sign and we were only going 1 miles per hour and we actually bumped into another car, we might be going slow enough that nothing really happens. The guy might get a little mad, but hey, nothing happened to his car. However, if we're going a little bit faster, let's say we're also now going 35 miles per hour and we hit another car, there's probably, well, there's more chance that a collision will occur and there will be some type of dent or damage. However, if we're on interstate and going super fast, this is going to pretty much create damage every single time we collide with another car. So increasing the temperature, increasing the kinetic energy, it's going to have more effective collisions, so it's going to increase the rate of the reaction. Now the last one is catalysts. Now catalysts are substances that you might have already learned about these in biology, and they increase the reaction rates by this unique way of lowering activation energy. Now, they take place in the reaction but are unchanged when the reaction is complete. So they help these two different molecules react. So these molecules kind of are connected to this catalyst, and these catalysts helps them break their bonds and form new bonds, and now it's left behind unchanged. So this catalyst can actually be put back into the reaction or recycled and used over and over and over again, because this is the same substance that it was in the beginning. Now, you might not know what activation energy is, but we'll be talking about this tomorrow in class.